Alright, so now we want to solve some equations that involve logarithms. Again, just to add to our toolbox of methods we have to solve equations, we do want to be able to solve ones that involve logarithms. Okay. One of the things we'll have to be very careful about here is that we do need, the method that we choose to use does require us to check our solutions. Sometimes we come up with what are called extraneous solutions, so we won't lose any solutions when we do this method, but sometimes we, through this method, create an extra one. So one way we know it's not a true solution is to check. Okay. So essentially what we're going to do is combine all the logarithms as best we can and isolate it. Okay. Then we'll convert to an exponential, and you'll see how that will help us solve for the x through the variable. Okay. But again, we're going to have to check our solutions, because one of the things we do when we combine logarithms is we use log properties. Okay? And the log properties are only good and valid when you have logs of positive numbers. Okay? But since right now you see in equations we have logs involving x's, and we don't know the value of x until we solve. Once we solve, we'll go back and plug back in. Okay? We can't give it any solution that would result in the log of a negative number. Okay? But again, our general method is to try to combine the logs, put them all on one side and combine them through properties, and then we'll convert to an exponential. Okay. Alright, so taking a look at this first one, we have 3 logs. Okay. Again, one thing we're going to do is put them on the same side. So I'm going to move this one over here. So I have log base 3 of x plus 6 minus log base 3 of x plus 2 minus now log base 3 of x equal to 0. Okay. And then I combine these 3 logs. So when I have, remember in this case subtraction, I'll have log of x plus 6. Log minus log will be a log divided. So divide by x plus 2. Here's another one, so I'm also have to divide by the x. Okay. So again, that's just, you should review your log properties. But the log minus this log would be the log base 3 of x plus 6 divided by the quantity x plus 2. Okay. So the first one we've done is combine it into a single log. Okay, but again, the idea is all your x's, the variable we're trying to solve for, is stuck inside a log. Okay, this is the first time this is happening to us. We have to figure out how to get these x's out of the log. Okay. Well, the reason we combined it into one logarithm is now we're going to convert to an exponential. Okay, so remember, log base 3 of a number equal to 0 means the same as 3 to the 0 power equals x plus 6 over x plus 2. Okay, so remember, if you go back and look, this is converting a logarithmic equation to an exponential equation. Okay, and if you go back and look in simpler ones, it was something, I'll just take something like log base 3 of m equals p. Well, remember that meant 3 to the p equals m, and that's all that we've done here. Okay, so now keep in mind 3 to the 0 is 1, and so we have an equation, no exponentials, no logs. So hopefully an equation that looks familiar to us. Okay, so it's a rational, we know how to solve this. Okay, I'll clear fractions and continue. Okay. So let's do that. Okay. So let me multiply both sides by the x plus 2. So I'll multiply the right by x plus 2 and the left by x plus 2. Okay, obviously on the right side it cancels, and over here on the left I'm just left with this. Okay. So I distribute and I can see I have a quadratic. Thankfully I know how to solve quadratics, so I get 0 on one side, so I bring the x over, so it's just a plus x, 2x minus the 1x, and then the minus 6. Even better, this quadratic factors. So x plus 3, x minus 2 equal to 0. Okay. And so I have my two solutions, -3 and 2. But right away I'm going to write down check. because we have to check. But right now, those are our two possible solutions. So I just take each one. I'll take x equal to -3, plug it back in the original, and then I'll take x equal to 2 and plug it back in the original. Okay, and again, I can check it all the way through, but at least I have to make sure by using all the properties of logarithms that I did, that I'm not trying to take the log of a negative number. Okay, so going back to my original, again, all the way back to the original, log base 3 of x, which is now -3, plus 6, minus log base 3 of x, which is -3 plus 2, is supposed to equal, right, we're checking, log base 3 of x, which again is -3. Okay. I can see right away this is not going to work, right? You can't take the log of a negative number. It's also true here. So this is false. So x equal to -3 is not a solution. Okay. If I check x equal to 2, again, my original is log base 3 of x, which is now 2 plus 6, minus log base 3 of x plus 2, 2 plus 2, is supposed to equal log base 3 of x. Okay. Well, this all looks good. I have log base 3 of 8 minus log base 3 of 4, and I want to know if that's log base 3 of 2. But again, I'm taking logs of positive numbers. So that's all I really need to check. I might finish it just to see that I'm correct. But remember, I have log minus log. But again, the key is all these are logs of positive numbers. Okay. But if I just take it one more step, remember, log subtracted is 1 log divided. And this is clearly true. Okay, so then my only solution is x equal to 2. You have to check when you use these properties. The very first property I used was to combine logs. That's only true if I'm taking the log of positive numbers. So I go back and check and make sure those are logs of positive numbers. Let's try this with a different equation. Okay, so I have log of x plus log of x squared. Okay. Keep in mind that the base is not written, so this is the common base or base 10 logarithm. Okay. But again, we're going to combine the logs, convert to an exponential, and solve the equation. Okay, so log plus log, remember, would be 1 log multiplied. So x times x squared. Okay, so before I go on, I'll just call this log of x cubed. Okay. This is where I convert from a log to an exponential. Remember, this is base 10, so the idea is that x cubed has to equal 10 cubed. Okay. Well, this is let me write down 10 cubed, right, is 1,000. Right, this is a degree 3 polynomial equation. It's usually not that easy to solve, but it's just x cubed, so I cube root each side. And x equals 10. Okay, again, keep in mind, as soon as you write that down, you want to write down check. If you combine logs, which is my first step here, you have to check. Okay. So the only possible solution is 10. I just want to see if that is in fact correct. Okay. So again, I go back to my original, not after I combined, okay, but in the beginning. So it's log of 10 plus log of 10 squared. Okay. And the question is that equal to 3? Okay. But again, I have log 10. I have log of 100. As long as I'm taking logs of positive numbers, I should be good. Okay. And then I might take it one more time. Remember, adding logs, that was 10 times 100. And in fact, the log base 10 of 1,000 is 3. So we do have one correct solution. All right, so we'll do one more. So here I'm going to use natural logarithm. Okay, so when I convert, my base is e. Okay, again, I have 3 logs, and then my first step is to combine those all. And then I'll convert to an exponential. So this is similar to the first one we did. So I have log of 5 plus 4x. Remember, subtracting two logs is a quotient, so that's 3 plus x and 3. So combining these three logs is log of 5 plus 4x over 3 plus x times 3. When I convert, remember this is base e, so 5 plus 4x, I'm going to write the 3 in front here, 3 plus x, would equal e to the 0, which is obviously 1. This is an equation I know how to solve. This is a rational, similar to the first one. So I'll multiply both sides by the 3 plus x. On the left it cancels, so I have 5 plus 4x. I'll distribute over here, I get 9 plus 3x. Nothing better than a nice quick linear. So subtract the 3x over here, I get 1x. Subtract the 5, I get 4. And right away, the first thing I write down is check. Okay. I only have one possible solution. I just want to make sure that it is not resulting in logs of negative numbers. So again, I go back to the original, not after I combine, back to the original, and plug in 4. So I have ln of 5 plus 4 times 4 minus ln of 3 plus 4 minus ln of 3. Question, is it equal to 0? Okay. But again, that's saying ln, that's 5 plus 16, so 21. 3 plus 4 is 7. And again, these are all logs of positive numbers, so I should be fine. Okay. If I want to check, I can go maybe one more step. Remember, now that I know the log rules work, so it's 21 over 7 times 3. And that's a log of 21 over 21, which is log of 1, which in fact does equal to 0. So my only possible solution, x equal to 4, did work, and I have one solution.